The title of the talk is Big Data, Challenges and Opportunities. As a matter of fact, I will tell you 3 stories, and then you'll decide which story you like better. So, this is big data. I think we've been talking about the data, in the conference already. Data comes from all kinds of sources, digital pictures or videos or posts to social media and things like that. And there's a lot of them. So there's a lot of data coming up every day. So I'll start with the first story. So what I would like to do is to tell you the story how it is told by the business perspective first, and then we'll have a little minute to review it. If you look at what the media says, big data is becoming a big thing. So if you think of McKinsey has a report, big data is a new frontier for innovation, competition, productivity. The European Commission is saying data is a new gold, and they have an initiative for opening up the data, public data in the public sector. So why do they do that? Well, first of all, there's not even a definition of what big data is, and I found one that I found it very interesting because it's very nice. Big data is anything that is big enough so that the existing software tools are not able to handle it. So, namely, the databases or whatever. So that's a very nice definition because, as a matter of fact, you can use it as time goes. So data will grow. The interesting thing is now the data is fast produced, and there's a lot of data, but it will be more data. And there will be more data, there will be more tools, and it's like here, we come into a situation where data is like data science. The scientist knows that for a long time because they have a lot of data science and space. But now the industry is experiencing all the amount of data that didn't have it before, and they're catching up. So this definition is quite good because it's not defined in terms of the size of the data. The data sets will increase in the future anyway, and also it varies about the sectors. So it's different, it can range from terabytes, which is not big data for some definition, to petabytes or something like that. So data is everywhere, so that's what McKinsey figured out. There's not much really of a discovery here, and it's important for what? So what is big data supposed to do? Well, it's supposed to create value, at least what McKinsey is telling us. So let's review what they say. Creating transparencies, discovering needs, expose variability, improve performance. Segmenting customers so you can target people better. Replacing support human decision and making things automatic and not manually anymore, and finding new business models. That's what they say. This is one of the examples of how they claim that this could be the basis for competition, growth, and individual firm. And there's an example here. It's a particular retailer that they don't mention the name, that because they dig into the data with new analytics will actually improve their operating margin of 60%. Now the question is, how do they figure it out 60%? This is the kind of report that the business is doing to define the opportunity. And then they figure it out, how do I measure that? And they say, well, I should consider only those actions that are related to the data. Anything else is not at 60%. So I'm only quoting what they say at the moment. But I think it's interesting, they identify a few sectors that are promising. Healthcare is one, public sector administration is one, but there's a catch there because there is not any incentive to publish data. So the data is typically not digital, and they need to be transformed and make it open. And unless there's a push for that, they're not going to do it. Global personal location data, well, you know about it. There's a lot of risk because there's a lot of data, personal data all over the place. Retail and manufacturing, these are the areas where McKinsey has identified the promising sectors. McKinsey figured out that one of the shortage and the limitation about that is that there are not enough talent people around. Typically, you need people with a lot of expertise, typically with a PhD, in computer science, maybe in analytics, in data mining, learning, machine learning, and there are not too many around. And that could become a limiting factor. So that's what the business is telling us. They also identify what they call issues. I'll go more technical on that, but I'll just go very quickly on that part. They call it about data policies, which is typically the technical part. How do I store and compute the data once I have them with analytics, and new kind of analytics. They call it technology and techniques. I like the techniques word because it sounds very old-fashioned. But it has to do with privacy, security, intellectual property, liability, access to data because data is from different sources, and industry structure. That's the interesting thing, that not all sectors are the same. An example here is there's no pressure in the public sector. So whereby in other sector, they might be driving by profit. That's not the case in the public sector, although there's a lot of potential there. So typically, if you look at the challenges in big data, you can classify them in 3 categories: data, process, and management. I just went through a list. I didn't want to put them into the category, and I go quickly on that. First of all is the volume, because the difficulty is how to deal with the size of this data. These are some numbers that you can read. It was interesting, there was a gentleman from Twitter before. Twitter generates 7 and more terabytes of data every day, and Facebook 10 terabytes every day. So you can imagine, not to mention, for example, intelligent sensors. There's something called the Internet of Things. The future way of using internet with sensor intelligent and will drive and sending all kinds of data all over the place. So then all of a sudden you will have a flood of data. The variety is actually an important factor because you have a multiplicity of types. So not only you have structured data, you have semi-structured data, and you have raw data. Typically, the software tools that we have are kind of specialized. The relational database work very well with structured data. With text, they don't work at all, and with raw data, they don't even know what it is. Try to store pictures in a database, and you'll see that. So the other challenges, they're not really technical, but it's important if you are interested in your business or your development in working with big data, is data availability. Is there data available? And very interesting, a good process will typically make a bad decision if the data is not good. And that gives to the data quality. How good is the data? How broad is the coverage? If you have a data that is indicating a disease in certain location, and some of the location have bad quality data, and in some other location is quite good, then you might end up actually doing the bad analytics, because then you are predicting something that is not based on consistent data. That's a very important applicability. You see, there's an example that a colleague of mine has made about the flu, and that really has to do with the data quality. Velocity, there was exactly the presentation before, talking about string computing. So it's clearly an issue. But I think the most important issue that is not much understood is what they call veracity. So again, how can we cope with uncertainty, imprecision, missing information, or even misstatements or untruth in data? There's a lot of issues here. And data discovery is a big challenge. How to find high quality data out there on the web. The people at Google, they're working hard on that. There's a group of people that work on Google tables, and that's exactly their challenge, data discovery. Once they have the data, they can aggregate it and present it with some kind of visual. So again, determine the quality of the data sets and the relevance to the particular issue is quite difficult. And these are all open questions, so these are all areas of work, both in research and development, that should be addressed, and combining multiple data sets, because that's actually the difficult part. Again, I'm going through the list. Data comprehensiveness. So, are there areas without coverage? an example. Let's assume that you would like to analyze data that has to do with geography, which should be no problem, except that you may end up in an area where you are not supposed to gather data. So how come you're not supposed to gather data? Why am I not supposed to gather data? Because maybe there's a security issue, there's a military area, and the data is not to be disclosed. You see, these are some of the things that are making things quite difficult when you are trying to use the data for some meaning. And obviously, personal information. The interesting thing is we tend to be very concerned about our privacy and what people do with our data in the real world, but when we are in the digital world, somehow, it's amazing how we become very relaxed. I have 3 kids myself. Well, there are actually no more kids, but there are 3 teenagers, well, not even that, 21, 19, 18. I don't know how to call it, grown-up girls, okay? And, well, that's a generation where they use Facebook and all kinds of stuff, and that's life, that's part of their life. It's not part of my life, it's part of their life. So at the end of the day, you have a lot of personal information in the net, no matter whether the security of Facebook is restricting that or not. So it is very important that actors here need to kind of sit on the same table and try to define what is reasonable in terms of some regulation. What does it mean actually? A realistic reconsideration of what privacy really means. Okay, I think Facebook has kind of changed it. So, interesting enough that since we know this is like a developer conference, I think this is quite important here. We shouldn't become data dogmatism. So, yes, data is important, but it would be like if you're trying to go to a doctor and rather than understanding what you have, the doctors have a computer, he'll check you out and then they give you a receipt or he'll tell you what kind of disease you have. I think data is only one part of the story and there should be something more about data, even if you analyze the data as much as you can. So that's there's a lot of issues that have to do with the data and less about the technology. So data discovery has to do with tools, but also it's a very complicated ecosystem where many actors have to play properly. The process, well, there's a lot of challenges. For example, how to capture the data, how to combine them together, especially when 2 objects have the same kind of meaning but they're different kind of format. Transforming the data into a way that it can be analyzed and you need to apply rather sophisticated technique, and then apply and model it so that it makes sense to work on the data. And then, interesting enough, which is very important, once you have a result, very few people will understand the result. So let's face it, unless you have a visualization that clearly shows it, then very few people outside the domain expert will understand what you discover. So that's also, there's a lot of work that needs to be done in the visualization of the results. On the management part, we're talking about data privacy, security, and governance. But this is not really new. It's only that the scale is so big and then everybody's using it. Because if you think, this is a quote from a colleague of mine, Michel Blas, very famous in the database world, in the modeling, and he's talking about data warehouses. It has nothing to do with the new kind of Hadoop things, but at the end of the day, the 2 issues are legal and ethical. So it's only that we have more data and data as part of our lives. So it's becoming more and more like a daily business. So I'm taking a second together to review this story. That's the story that the business is telling us. So my point here is all about intention. What is the intention that we are trying to dig into the data? So if my intention is good, it will be good. If my intention is not good, it will be bad. And this is not told. So nobody will ever tell you that. They will tell you that big data analytics will increase productivity, innovation, margin, targeting people, and all kinds of stuff. But at the end of the day, you can misuse the data in a way or it is not actually said. So certain things will not be said, but it will be done. So, that's all about business I wanted to mention to you. I think for me it was important to mention it because the rest of the presentation is more on a technology challenge. And that's the second story. And then I have a first story that I like to tell you. So these are some of the examples of what you can do by analyzing data, log analytics. Everybody is talking about it. That's why the gentleman with Twitter has developed his Lambda architecture in the presentation before, because they can do a lot of kinds of computation. There's fraud detection, because you can start looking at patterns in the raw data and figure it out who is actually, for example, using a credit card in an improper way. Social media and sentiment analysis are important. Sentiment analysis means I go on the web, I look all the tweets, and I try to figure it out by the content if there's a trend, like politically, who's going to win the next election in the United States? Can I just, by looking at the trace on the net, figure it out? That's called sentiment analysis. Okay, there's a lot of research on that, and there's a lot of interest. It's all about try to predict or try to understand what's going on. Risk modeling and management and energy sector. Energy sector is quite interesting because, for example, in Germany, there's first of all, there's a European regulation that says that in a certain amount of years, we will have intelligent meters in the house. I don't know if you know what is intelligent meters, but the gas and the electricity meter that you have now, it will become intelligent because it will understand how you use the data, and it'll send this data information to some place, which is the government. And the government will have all this data, and they will figure it out something. You see? That's an example of how you do things with big data. They could, for example, figure it out that you shouldn't do this thing or that thing. Maybe. The energy sector is definitely an interesting area where you have censored them. I had the pleasure to talk to a few people about this topic, so I quote a few people. One of them is Florian Vast from EMC Greenplan. What he's saying is basically saying that if you have a lot of data, you need to put the analytics to the data and not the data to the procedure, which is basically what it was done typically in the old relational database world. He also saying something interesting, that with terabytes, there's no problem. You have databases out there that are handling terabytes. Data warehouse with terabytes, no problem. When it goes to petabytes, then it gets very complicated. The catch about this assumption is, who really has a petabyte problem in the enterprise? Because petabyte is a lot of data. So anyway, this is interesting because it confirms something that is called the Gray's. Jim Gray was a scientist unfortunately he's no more here, but he was very famous in the database world, and he started to work together with scientists, so trying to use database technology for data science. And he came up with some laws for data engineering, and he said, take the analysis to the data. That's exactly what is happening now. So the issue here is that now we have all kinds of separate parts, ETL, business intelligence reporting, analytics, all different products. And it would be nice to have a seamless integration of those. It's not happening, even with the new technology, and you'll see why. So that's a wish, but in fact, this is not really happening. One of the problems that old relational database technology has a lot of problem with this new big data is that the underlying architecture, which is basically what my colleague before also mentioned, was not really made for handling big data with unstructured and not formatted parts. So basically you have a technology where the underlying model is not really made for that, and try to fix it is quite difficult. That's a quote that is made. So I asked a few people, and I also asked some people that I think they have something to say, like Werner Vogels from Amazon, the CTO, and he said, well, that's what he's quoting. He's basically saying that the way they do analytics is different. It's like exploratory. So in the old way, you knew exactly what to ask, and you have a schema, and you were basically getting something back. Now they explore and figure it out what they want. Of course, he's also trying to push their own cloud. That's why they couple very much with cloud. But anyway, that's exactly the same thing. At the end of the day, you are exploring. And by exploring a huge amount of data, it takes time. So, and that's actually the thing, that in order to explore the data, you need the time to do it. So batch processing. But that's actually the issue here. Now, batch processing works very nice, but when business start to think, oh, I could do something useful with the data, they want it now. So that's the funny thing, you know, they're not happy with batch processing, they want real-time analytics. That's why now you have all this fade on real-time analytics, because people want immediately to understand what the patterns are. Of course, this is actually quite difficult because you will see that the tools that we have are typically batch processing, and although you can patch things together, it's not really obvious. On top of that, most of the data is semi-structured or unstructured, whatever you want to call it, and this makes things quite complicated. So, how's the situation at the moment? If you know, I'm a vendor neutral. That's a good thing about it. I've been vendor neutral. I don't have to sell anything. So I observe. So typically, when you want to do big data analytics, you have this configuration. You have a parallel database or a NoSQL data store kind of connected with an Hadoop batch processing. Okay. So you can see all kinds of variation, you get all kinds of vendors. All vendors will tell you this is, you know, their solution is the best. But at the end of the day, there are some concerns about the performance of that, because you will have a huge amount of data stored in the batch. And when it comes to the real time, you have to put it into a parallel database or a NoSQL database to do whatever they want. So, when it comes to scalability, the three aspects that typically are looked at are data volume, we talk about it, hardware size, which is no more a big issue because, you know, hardware is commodity, and concurrency. We talk about in several of these presentations about the CAP theorem and eventual consistency, all kinds of stuff. I had an interesting discussion with Basher, say, I wouldn't have my bank account eventually consistent update, and then we have a discussion on that. So, and there's also a lot of interesting things there. So, but let me just go through. The question is, which platform for analytics for big data? You need to understand that big data started in two different worlds. I myself, I'm from the database perspective, but the interesting thing is, you know, big data in the database world started in the 80s. And the key was parallel databases. Unfortunately, parallel databases are neither necessarily easy, nor there's not even open source implementation. So the interesting thing is, in all these years, there are actually more than 20, the community didn't really come up with an open source implementation of a parallel database. But things like shared nothing architecture, declarative set-oriented queries, and divide and conquer, MapReduce stuffing. You have an Teradata. Teradata is the database that is actually, you'll see, used in very data-intensive application. I have something about eBay. And then under sometimes the name New SQL, which is also not necessarily a nice name, but it's basically re-implementation of relational databases where they re-implement the entire internal parts. And then you have, HP Vertica, IBM Netezza, Teradata, Astrodata, EMC, Greenplan. Interesting thing, you see that you have always a big company / another company, they all been acquired. So Teradata acquire Astrodata, EMC apply Greenplum, HP apply Vertica, and of course, because all of these other technology that were like new implementation of relational databases for large amount of data. In parallel, the system world, so the people that are used to do system implementation, networking, and all that stuff, they had a problem. And late in the 90s, you have, the Hadoop, the MapReduce, of course, inspired and by the big web companies. And then you have the Google Big Table, that they use it, you can't. And Amazon Dynamo, you can read the paper, but you can't use the system. That is why you use Apache Hadoop, because that's open source. So that's the reason why. So I've taken some concept from my colleague Michael Carey, that is a quite famous database guy, to review the two stacks, the parallel database software stack, and then we review the hardware software stack. Now, let's start from the bottom. At the bottom of a relational database, you have a storage manager that is row or column, record-oriented, and you can basically structure your storage manager like that. Then on top, you have your relational data flow layer, runs the query plans, and understand about the local storage manager, and then the share nothing storage services. And on top of that, SQL. There's no other way to get into this system as with SQL. That's very important. You can't break it. That's the thing. You can't turn it apart and decide to use only the storage manager. Oh, I wish I used a storage manager, or you need to go through the SQL. That's actually the problem. It's a monolithic thing. And it's not even easy to use because it's parallel databases. And there's no open source implementation, so nobody can innovate. That's the thing. It's actually quite bad. If you look at the Hadoop software stack, it doesn't look good, but it's completely different because you start again from the bottom. You have this Hadoop distributed file system. If you think about it, it's a byte-oriented file abstraction. Files appears as a very large, contiguous, and randomly addressable sequence of bytes without even understanding the boundary. There's no more like a record where you normally, you never break a record in two parts. Here are all bytes, and then the system does not understand that, there's a boundary that gives a record meaning. So you can actually have parts of your data that goes into other blocks. On top of that, you have, for example, HighBase is a key value store. And this can be, and that's the interesting thing, that you can access that either directly by client or via the Hadoop MapReduce. So you see, it's no more monolithic. So you can start. I was listening to the presentation of RIA Core this morning. That's a good example. They have a core, and they can just have it. In the parallel database, you can't say, I have a parallel database core and do what you want, and you get the whole thing. And so it doesn't look nice, but it's actually no more monolithic. And the MapReduce and Hadoop is the only thing that allows you to process a huge amount of data nowadays. So batch analytics, and on top of that, the interesting thing that people that are very smart, they realize that not everybody is so smart, and when you start using a system that's quite complicated, they started to have a higher level of abstraction. And so in the Hadoop ecosystem, now you have high-level languages. Hive, Pig, Pig Latin, JSQL. And these are high-level languages because it's easier to handle that in a kind of, I would say, SQL style rather than only programming in MapReduce. So, Michael Carey, that is not a pro Hadoop guy, I took it on purpose, had done a kind of nice pro and cons about Hadoop. These are the pros. Okay, open source, non-monolithic, definitely scale, okay, and it has support for replication, and you don't have to have manual operation. So at the moment, Hadoop seems to be the solution. Everybody's using it. But I think it is also looking, and I think it's very important that we look at also critically, there's also something that is not necessarily a good thing. I slightly changed the phrasing. It was much stronger. I said questionable. He said something much negative. But I would say that the points are, first of all, it is questionable at least to have a layer at the very bottom that has bytes, and then on top start having something that looks like a declarative join. Okay, so because the level of abstraction goes higher, and then you have bytes on the thing. And that's exactly the thing that you have, everything that is performed on MapReduce, okay? And certainly, if you try to perform something like a join with MapReduce, you can do that, but it's not necessarily done for that. So, and now a very interesting thing that I think it was quite interesting, if somebody of you attended the previous presentation, a lack of schema. The NoSQL movement said, well, if I don't have a schema, I'm more flexible. True. But by not having a schema, I'm losing all the information that I might have, and in the future, it might become very difficult to maintain those systems. And Misha Carey actually said that was actually one of the early lessons that the database world has to learn, that really is becoming difficult even to fix bugs. Maybe the thing will be addressed, but that's definitely, Hadoop is not only good. And I wanted to give you some quotes here, because I think he's saying that the database community was sleeping. You know, in all these years, they really didn't understand what was going on. And then they woke up. And the other people, the system world, had already implemented systems that had very little to do with the database. And this was a keynote that he did in Berlin this year. And that's actually what he's telling to the database community. So I think it's good, because I don't think that here is a mix. And there was a lot of discussion about, the pros and cons about that. I think it's always important to critically review that. There are two projects that are happening right now. Carey is working on a project called Asterix at UC Irvine. He will come up eventually this year with an open source Apache style Hadoop variation of that. Interesting to have a look for some of you that are more into the research part. And there's another project called Stratosphere at the Technical University in Berlin that is also trying to do a slightly different implementation of the MapReduce thing, just for your information. So, but since everybody's using Hadoop, let's spend some time on Hadoop. Hadoop is really an ecosystem of projects. As you see, that's what I was referring to, PIG. 60% of these cases of MapReduce using a language that is like an algebra, PIG Latin. PIG is really an engine for data for languages. Hive was developed by Facebook, also inspired by SQL, and 90% of the cases of MapReduce are using like that. And there's a lot of other things. So at the end, you have an ecosystem, and that's why you have a distribution, a Hadoop distribution. So scale and processing unstructured data are the key important things. And then you can do all kinds of interesting things if you combine it with machine learning, recommending engines, and that creates the business opportunity that we talked about before. The main limitation of Hadoop is batch processing. And now some people are working on trying to fix it. There's the few other limitations of Hadoop, one of which is, for example, that it's difficult to use. And it has a centralized node. If you're using the Apache implementation, you have a centralized metadata store as a master. So if it goes down, then when it comes up, it might take a long time. But what other Hadoop distributions are doing, they are re-implementing part of that. And so you have, for example, certain Hadoop distribution, commercial distribution like MapR, they have re-implemented the file system. So to make it different. So you have like a map-reduced power, but the implementation is different. And then you have this dichotomy again. You have the analytics, map-reduce Hadoop, and then you need the real-time part. And then you have all these key value stores, and then you can use, for example, NoSQL database, like, for example, the gentleman mentioned it before. As we said, Hadoop doesn't need a schema. And I was curious, and I asked, actually, Werner Vogel, why did you choose Hadoop? Because Amazon is using Hadoop. That's his reply. I found it quite interesting, this reply. If you read it carefully, the first is a technical issue, is scale. The second is open source. And the third is basically saying everybody's using it, so better be there. And then he said, 3 years later, we did the right choice because they're making a lot of business with the cloud. So it could well be that the ecosystem will start changing and business intelligence vendor will start adapting to Hadoop. And Hadoop will become like a commodity. You have to remember that there are other systems out there. They call it new SQL. I chosen one just to mention one. Now Vertica is now HP, but you can choose Greenplan or whatever. They actually try to do also analytics on big data, and they are SQL based. So the column database engine, you can argue on that, but they provide standard ACID transaction. So. And then it becomes very difficult when you start looking at all this system, when you start talking about performance, because there is not really a way to do a benchmarking on that. I just wanted to give you an idea how, for example, analytics are used by one large web company. But this is very specific, is eBay. The question is, how many eBays are around there? So how many of you will eventually need it? But eBay definitely need it. So I had a chat with one of the technical guy at eBay that is responsible for that. And the main technical challenges for eBay in terms of big data are the I/O bandwidth, the concurrency and the workload management. Actually, at the end, and the data movement between the system. You see that the interesting thing that eBay, this is not completely actual, but very fast. I have 10 minutes or 5 minutes? 10? 7 minutes. Oh, I have to go very fast or skip. Anyway, I can tell. So eBay is actually using 3 systems for analytics. The one that is mostly used for structured data is a Teradata. But then they have another system where they need to have denormalized relation, and is a second system, is a Teradata system. And they do user behavior. They wouldn't be able to do it with normalized data. And then they have a third system that is Hadoop for unstructured complex data. And they do behavior user. The difference is that the number of users that are on Hadoop, it may be 10, and about the other system are used by the entire company. For example, eBay, only for the search engine thing, they have more than 1,000 people working on that. So basically, at the end of the day, I have many more slides on that. You can, when you will be able to download, you can see. They have basically come up with several tools for several work. Now, the unstructured data is definitely handled in Hadoop, and that's actually what eBay does. And these are some of the, let's say, the tools that they use. As you see, it's not an easy thing. You need a lot of complexity also to manage all these tools. Seamless integration is definitely not really something that is happening. So, and why do they do that? Because they can then have improved buyer experience, search optimization. I was shocked when he mentioned how many people only working on the little fenster, on the little window where you do a search in eBay. Buyer protection, fraud and mobile commerce. That's what they do. Okay, so Who are the typical Hadoop user? Well, you can distinguish into class, advanced user, maybe there are some here, but how many advanced users are there? Well, you need to have probably a PhD from a good school. For the other one, Hadoop is quite complicated. So the vendors are trying to expand or change the Hadoop distribution with kinds of improvement. And these are some of the challenges that we have. One of the things is that to bring Hadoop in critical business project is not an easy task, especially if you don't have enough skillful people. And on top of that, protecting data against application and user errors is not an easy job. So, what about the cloud? The people in general are concerned about putting their data on the cloud, but business like Amazon is doing a good job with that, doing a good business. Now, what about traditional enterprises? Here is an interesting quote. I like this quote very much because Mike Stonebreaker is a very famous colleague in database. He did all kinds of databases. He hated Hadoop, but he started many companies, one of which is called VaultDB. VaultDB is not focused on analytics. And then read the last sentence. To facilitate this architecture, VaultDB offers an Hadoop connector. So basically, even somebody that didn't like Hadoop at all is actually looking at the market and say, well, people are using Hadoop, so I better have a connector. So I might skip some from that. This will be, for example, CouchDB. If you talk to CouchDB, they will say they will have all the data in the Hadoop and then use it, the small part in the real time, NoSQL, and then basically send it back to Hadoop. You have something like a connector, Apache Scoop. That is a tool where you can basically transfer bulk or relational data into Hadoop. That's what he thinks. He thinks that the Hadoop will be a commodity. The only catch is actually obviously NoSQL base, and this is not obviously the only way. I will skip that part, but just for you to know that it's very difficult to do a benchmarking of the systems. Everybody is claimed to be fast, scalable, but there's not any easy way to do a benchmark on that because, for example, the classical database benchmark, like TPC, they don't work because they are thought for data warehouses where you have ACID transaction, and none of these systems have it, so they don't qualify. So, to make it short, I think you should have a look at this. There's a benchmark done by Yahoo Research. There are no more there. They all disappear. But you can actually have that as an open source. I don't have the time to go on that, but this is it. And with that, you could actually have comparison between various systems. The interesting thing about this benchmark that the kind of query are not the typical query that you have in relational database. They're very simple read query. And you have two workload, read only or read and write. And they are very simple, but with a lot of data. And that's the only benchmark that is out there that is not vendor-made. Because that's the question. If you ask the question to a vendor, how do you measure your benchmark? I did the benchmark. But if the vendor does a benchmark, it's a vendor's benchmark. Okay, so in here, this is a neutral open source benchmark. So this is another interesting quote. How easy is Hadoop? Well, it depends. It depends on how skillful you are. But that's really a concern. John Schroeder is actually, by the way, the founder of this MapR, which is a Hadoop distribution. So maybe there's something that need to be mentioned, that enterprise search, which is actually now a new way to finding data. And I'll skip, and I come to 5 minutes. I have this, and then I have the ending of this story. This is what I found in a report of this year from an analyst of Deutsche Bank in London. I just quote it, I know, paste it in, exactly as it is written. No matter what the truth is about this report, because nobody can really read the future, but you can see how conservative this attitude is. The very scary thing is the number 2. So, to what extent big data is at the moment really in the enterprise? I think the future will show that data will come from all over the place, so you won't be able to escape it. But I think this is something to consider, especially when there's an attempt to replace technology in the place. Okay, so take the time for that, and I have 5 minutes. And I use the last 5 minutes for something that I'm very keen of telling you. That's the first story about big data that nobody is telling you. Or at least very few people. I think one of the. This is the other story about big data. The story I like. The story about big data is the following: that nobody or very few people care about using data for something that has a social meaning. Very few people. Not all of them, but especially in our research world and development, there is sometimes not really this interest. And I asked myself, why? So, I took this quote, which I think is quite good, because you can say, well, you can call it the common good challenge for big data. I think that sounds quite nice, because there is an opportunity. Of course, you can misuse it, but you can use it nicely. Now, the World Economic Forum, these guys that meet in Switzerland every year, they even discussed about big data with a report called Big Data, Big Impact, New Possibility for International Development. So that's actually the exactly summary. What is interesting, and they have a report that you can download from the web, which is called Big Data, Big Impact, New Possibility for International Development. And this is taking the attitude of looking at how you can do with big data something for social. And they identify 3 examples. There is an initiative for UN called UN Global Pearls, and this is the website. Then there is a global viral forecasting, that you can forecast on diseases, and then platform. And then I ask a few people, a few questions. What are the main challenges? Why researchers, do not really look at that. I asked them about the Google research and IBM research, a consultant, somebody Microsoft research. What I like, in summary, is what is written. Paul Miller is a consultant, so it's not really based on a company, which is important. He said, look what they say about what developers should do. Work on stuff that matters. Well, this is a good thing. Let's work on stuff that matters as well. And at the end of the day, if you want, you can download the full report. There's a website, you can download it. I like to finish with some thinking. It's always possible to follow and say, okay, I use big data because my margin will be better, my productivity will be better, I do more money, I develop very interesting technology, and there's a lot of great brains here and great developers, and maybe some managers. It would be nice if we could also use some of our energy, and I say we because we own that, to maybe go in that direction as well. And that's the first story that I wanted to tell you, which is not necessarily the one that normally is told, neither in business conferences nor in technological conferences. Well, and that's the end of my presentation.